Hey everyone, welcome to the VMware Cloud Networking Academy presented by 27 Virtual. In this session, we're going to cover securing and connecting multi-clouds. Your presenter today is Rodney McIntosh, NSX-T expert. Enjoy the presentation.
We start with a quick caption of what we've seen traditionally, right? What are the adoption models? What are people doing and why, right? We find that a lot of customers have, of course, their on-premise environment where they're running their workloads. But as you start to dig a bit deeper, you start to realize that they have some of these workloads, or some other workloads, running in other clouds, especially your mega clouds, the like of Azure and AWS. Now you may ask, well, why? That doesn't apply to me, or maybe it does, and I really have some of the challenges, right? Well, in the case of Azure, we find that Microsoft has done a great job in making things very easy for customers that are running Windows virtual machines, as well as Linux machines, to essentially use their platform for disaster recovery as a service. Right? Using SCCM, you can go in and essentially choose that you want to replicate one or more virtual machines into the Azure cloud. It makes it very easy, very seamless, and you can fill back and forth, so on and so forth. So for those with Microsoft licenses and having a subscription to the Office 365 or Azure platform, it's just a natural fit, right? At the very least, from an exploratory point of view, let's explore it and let's see what's there. And before you know it, they've exploded into that and they've started to migrate a lot of their workloads there for DR purposes. Then, of course, you have other individuals that, in addition to using Azure, right, or maybe even as opposed to using Azure, start to leverage other clouds such as Amazon, AWS, right? In the case of AWS, in most instances, it's because of the services, the cloud services to provide, right? And because of the tools to provide to enhance development efforts. So you find a lot of developer type workloads being moved to AWS. This is not to say that you don't find your traditional replication of instances into AWS and so on and so forth, but more so, it's kind of for a new breed of application, a new SaaS-based application that we're building, or something that we're trying to do that currently our existing IT environment just has not been as adapt or as flexible as the developers need them to be, and therefore as responsive as the developers need to be. And so the developers are now moving those activities to the cloud, right? However, with all of this comes challenges, because at the end of the day, what happens is it still comes back to the IT ops teams to essentially manage this. Right? We need to have where we've moved workloads to the cloud for DR purposes, where we've added some additional workloads to the cloud because of these new development efforts that we have in-house. The point remains there still needs to be connectivity to and from them. And ultimately, there has to be security as well, right? Those are not things that, if you think about it from a developer perspective, that a developer cares about. Well, maybe care is a bit harsh, right? Not so much that they don't care about it, but that's not their focus, right? A developer's focus is to ensure that he or she can provide the services required, right? Plain and simple. Let's get the code out there as soon as possible. But coming behind that again is this huge effort to essentially ensure that we have connectivity to it, because without connectivity, we don't have the adoption that we expect. And of course, securing it. So with that, we find that these are some of the pain points and challenges that customers have when they are adopting multi-cloud, whether this was intentional or it just was an explosion. They just found themselves in this realm, right? Challenge number one, how do I ensure consistency, right, as it relates to my operations and minimizing the inefficiencies with the operations? What exactly does that mean, right? A lot of big words there. It means, number one, I don't want to have to manage 2 or 3 or 4 different platforms. Let's look at it from a standpoint of security, right? If I needed to go in and define security policies for my workloads on premise, I've got one set of tools that I need. To do this for Azure, I need to do this with another set of tools provided by Microsoft. For AWS, another set of tools provided by Amazon. All of these have different architectures, right? They have different guidelines. On top of the fact that they are individual tools. So now I'm going to 2 or 3 or 4 different places to create and manage firewall rules, if you like, right? So there's inconsistency as a result, because I now have to do things multiple times and have to remember to do that multiple times in some cases. And of course, I'm doing them differently. Structuring a policy here for my workloads on premise may not be the same if I'm trying to structure that same policy for something in AWS, right? Because of its architecture and what it provides support for. Of course, another concern is increased risk because of this inconsistency we find with the networking and most importantly, the security. How do I reduce that, right? I don't want my developers to develop applications and have the applications out there without any rules defining how we access the application, who, when, and how we access the application. I want to have the same type of robust security I have on-premise for my on-premise applications for those that are running in Azure or AWS. At the end of the day, in most instances, these applications are customer-facing, right? Whether that customer is external to your organization or whether that customer is internal to the organization, it's still customer-facing, and therefore it requires consumption, right? And of course, how do we reduce the difficulty with streamlining operations and, therefore securing these different clouds? And finally, ensuring that we can protect the workload without manual intervention. Basically, I want to be able to do it once, right? I want to go to one place, not to 3 different places, craft my security policies, push it out, and it goes everywhere that it's supposed to, and everything is protected as I intended to, right? So to the rescue, we have NSX Cloud, right? NSX Cloud provides us this paradigm wherein we can now have consistent security across the clouds. That is your private cloud on-premise. That also includes AWS and Azure today, right? So in a single pane, I have the ability, if you will, to define my security policies and have those security policies take full effect across the board in all of these clouds, where of course I have registered these clouds within my platform. In addition to having seamless security across them is also having control over the networking. How do I handle connectivity into these clouds, whether it's I'm using direct connect from my on-premise in, or I'm using VPN, or I want to be able to have a VPN connection between not just my on-premise and AWS, but also between AWS and Azure, right? And I want to have one set of, if you will, VPN appliance that I'm having to do this, as opposed to getting some other third-party appliance to do this for me, right? And therefore having to learn yet something else and manage yet something else. And then lastly, visibility, end-to-end visibility. I can't truly protect what I can't see. I need to be able to see what's going on in my data center. Check, we got that covered. But can I also sit on that same platform using that same tool where I have visibility and inspection into my environment, my on-premise environment, have that level of visibility and inspection into these mega clouds, like again of AWS and Azure? And the answer, of course, is yes. So with NSX Cloud, we're saying we can do the following. We can define our policy once and then apply them. And you will see how this is done, right? We can have granular enforcement down to the workload level. For those of you, and most of you I see were here last week, we talked about tagging your workloads, using those tags to define your groups, and then in turn, using those groups in your security policies. Nothing changes from that perspective, right? So I still tag my workloads, whether this time these workloads are in my private cloud or the workload, in addition to being my private cloud, exists in AWS and or Azure. There is visibility into them once I have the platform deployed. And what I mean by that is I would now see in NSX, I will see all my on-premise VMs, but right next to them, I will see those Amazon instances, and I will see my Azure instances as well. And just as I can apply a tag to my on-premise instances, I have the ability to do the same for these cloud instances. And just as I can go into define a group and specify one or more criteria that may be based on these tags for my on-premise instance, I have the ability to do the same for my cloud instances as well. And therefore, apply these groups, if you will, to my policies, my firewall policies, my security policies.
Hey, Ronnie, I do have a question. Is NSX Cloud something I would use at another provider like an IBM or a Rackspace, or is it only for AWS and Azure?
Today it's for AWS and Azure. So with our, what we consider our VCPP partners, VMware Cloud Provider partners, the like of IBM and Rackspace, and the list goes on, right? Those 4,000 plus. They would provide you an option to install NSX-T data center, right? Something we talked about in week 1 as an introductory about the different use cases for NSX was this ability to leverage federation. So in an instance where the cloud provider has provided you an NSX-T instance, you can federate between the on-premise NSX-T instance that you have with this cloud NSX-T instance being provided by said provider. And that's how you will manage that. NSX Cloud is expressly for native clouds that are running, that are based on non-vSphere hypervisor, right? So your Azure and AWS, they're not running vSphere, they're not running ESXi. So we have to provide some component to allow us the ability to manage those. Whereas if this were an environment like IBM Cloud, where the instances, or rather the servers, are running ESXi, then we can just drop NSX-T data center in there.
I see. So if we look at your slide there, if we look at the bottom, it kind of says data center on the bottom left. So I'm running, so is that right? I'm running NSX data center on-prem, right? And then I'm running NSX Cloud in AWS and Azure. Is that correct?
That is correct. So NSX data center is ran on-premise here, and NSX Cloud is what's operationalizing your cloud environment. Just for clarity's sake, this does not mean that we are running NSX Cloud as a component in Azure or in AWS. So the NSX Cloud, what we call the cloud service VM, actually runs on-premise. You deploy the VM right next to your NSX-T data center and you register it to NSX-T.
And then the example with your IBM and your Rackspace, we'd be doing data center on-prem and data center in, say, IBM. Is that correct?
Yes, you'll be running data center in both.
Great, thank you.
So as far as visibility goes, the same tools we have for providing visibility within NSX-T exists for providing visibility beyond the data center into the cloud. That means we can essentially use tools like Traceflow. We can use port mirroring. We can do all of these same things, right? We can have real-time visibility into the communications between the nodes within your on-premise environment and on-premise. Again, from a management standpoint, all of your management, right? That is from security to connectivity to visibility happens within NSX-T data center. right? You're doing all of this from on-premise, so you're learning one tool, and using that one tool or that singular interface, you're simply managing not just your on-premise environment, but also what you have in the cloud. So what I want to talk about very quickly now is how does this work, right? What are the steps required to make this magic happen? Sounds very exciting, but how does it work? So here I have a high-level workflow for both Azure and AWS. Azure to the left, AWS to the right, right? But what you notice is the first thing we do is we go in and we deploy the cloud service virtual machine, right? You do that. Again, you deploy this on-premise right next to your NSX-T and you register it to NSX-T. That's the first thing you do. So for anyone that has deployed NSX-T, during the deployment of NSX-T, there's an option to deploy a tiny NSX-T instance. The tiny NSX-T instance deploys Cloud Service Manager. Okay. Small, medium, and so on and so forth, those deploy your standard NSX-T data center manager / controller. But when you choose the smallest option, that deploys it as the cloud service manager. And that's all it is. So it's not like you're even downloading another OVA. It's the same NSX-T OVA that you're deploying. Just choose the smallest option, and that deploys your cloud service manager. You then, of course, log in, and I'll show you the interface in a moment in the next slide. But once you've done that, you then, again, register to NSX. And after you've connected it to NSX, you want to ensure that all of the network connectivity that it requires, that is, there's no firewall blocking, that we have routes to get us to the internet so that we can get to AWS and Azure, and of course that it has connectivity in NSX-T manager itself. We want to ensure that all of that's taken care of. Given that's taken care of, right, the next thing we do is within our clouds, we of course need to go in and set up the subnets, right? Because something that's going to happen is we are ultimately going to deploy a gateway within these clouds, within these VPCs and VNETs for AWS and Azure respectively. Think of these gateways as the equivalent of an edge node, which essentially is what gets installed. It's a souped up edge node, but an edge node nonetheless, right? There's some additional code that's wrapped in and layered into that edge node, but nonetheless it's an edge node that gets deployed into these clouds. So we have to go in and define, you know, the subnets for that. And we will want the edge nodes to be highly available, right? So we'll need to ensure that we set up the availability zones in the case of AWS, and the redundancy for Azure as well. Then, of course, we connect. And finally, the next thing we're going to go do is we essentially register the subscription, right? We run, there's a script, one for AWS, one for Azure. You run those scripts respectively so that it can create the accounts that you need, and it can essentially use that to register this into Cloud Service Manager, right? So you do that, and then you deploy your cloud, public cloud gateways. The next thing that you do, which I don't have illustrated here, is the fact that, and this is optional, which is why it's not here, is you have the option to go in and install the agent into the VMs. Because again, if you reflect back to something I said earlier, is we don't have hypervisor access in AWS or in Azure. Not to mention the hypervisors there, they're not even vSphere. Keep in mind, we're not talking VMC on AWS, we're talking native AWS and native Azure, right? So we don't have access to the hypervisor, and to make matters worse, the hypervisors there are not vSphere. So we can't install NSX bibs into the hypervisor. So what we do instead, and again, this is optional, you don't have to do this, we'll talk about what this means coming up in a moment, is we install an agent into the VMs that you need to create policies for. So in this next slide, you take a look at what the Cloud Service Manager interface looks like. Once you deploy it, you log in, right? You then go in and you say you want to add your account, whether that be an AWS account or an Azure account, subscription rather, you add those subscriptions. In this instance, we've added an Azure subscription. So you notice it shows this subscription has one account, there's one region, and there are 4 VNets associated with this subscription right now. Right? We can do the same for AWS. Now again, where you've done that and you've done the registration, the next big thing we need to do is we need to deploy the control plane, because CSM acts as the management plane, right? It connects to an NSX-T data center, and together they provide your management plane. But what about the control plane? As in essence, when I push, for instance, a firewall rule, who ensures that that firewall rule gets injected where it needs to be? Well, the public cloud gateway does. So within those 4 Azure VNets that we showed you earlier, you will choose the appropriate one or ones, and you select it and say action, and you say deploy cloud gateway. This cloud gateway communicates directly with your on-premise management components, so that when you create policies and you push those policies, it gets the policies, but it is now responsible for injecting the policies into the data plane. In the case where the VMs have the agents running, then the VMs are my data plane. In the case where the VMs don't have the agents running, then the cloud itself is providing the data plane, and we'll talk about that in a moment. So, assuming we've done all of this, all right, what you now have is a visibility of your environment. This is your cloud environment, AWS and Azure, within NSX-T. So if you look very closely, you see what we're illustrating here are the tags that are defined, or labels that are defined in AWS and also in Azure. Now, in the bottom, this is NSX-T. If you look closely, you see that NSX-T has tags that it puts in automatically for all of these things. In other words, when we discover a node and we discover any tag applied, any cloud tag applied to it, whether these cloud tags are system tags or user-defined tags, we apply them. So what I mean by that, for instance, this is a system tag, the one that says Azure VNet name. You know, in essence, what VNet is this virtual machine in? Which region is it in? These are system defined, right? No one tagged the virtual machine as such, but someone tagged the virtual machine with an app name of books-app, right? As you can see here, that was done by someone. Someone tagged this as web tier. But the point is, NSX discovers the objects and it assumes all of those tags. It basically imports all of that. So the beauty here is I can start using these tags that are cloud-defined tags, again, whether they're system-defined or user-defined, but needless to say, in the cloud, to be the basis for my grouping. And then use those groups in turn in my firewall rules. All right? So that's what you have here. And again, at the top, you're looking at my system tags, as I highlighted. And those bottoms, those are user-specific tags that were added. Okay. You notice also that there is this tag called NSX Network Default that exists both for your Azure and AWS. Once a workload is said to be protected, we add that tag in the cloud for the workload. That's how we know a workload is protected. All right? Basically, that's a tag that the public cloud gateway will attach to an instance if that instance is said to be a protected instance. Having these tags congregated within NSX-T again, I can now go in and start to build my membership, my group memberships, and build my firewall rules on this basis. So if you take a quick look at this example we have here, we're creating a group called Book App Group. Here's what we're gonna do. We're gonna go look for any virtual machine that has this tag called book-app, right? And the scope needs to be app name, right? Now, let's assume for a moment, this tag and scope is what we apply to instances of VMs that are running on premise. So let's assume that I have, one or two web servers that are running on premise, right? And the point is that's how I tag the guys that are on premise, right? But now let's take a look at the next two. We say, but go look at virtual machines again also, that also have book-app, but where the scope equals this AWS.app name. And if you look at the third one, it says this Azure :app name. So what we're doing is we're saying, go find all virtual machines that belongs to this book app, irrespective of where they are, whether they're on premise, whether they're in AWS, or whether they're in Azure. Go find them. We know the Azure ones are going to be tagged Azure app name, and we know the AWS ones will be tagged AWS app name. And as far as the ones that's on premise, we're not providing any prefix. We're just calling the scope app name. All right, so go find all of them, wherever they may reside. Congregate them together in this group because I want to specify a policy for them. Those are all web servers. I want to say traffic coming from anywhere, making a 443 request to this book app group that I'm creating, which includes all of my web servers, should be allowed access. And we're going to check layer 7 firewall to ensure that the request being sent is an actual HTTPS request, and call it a day. And here you see another example. This time we're doing it per tier, web tier, web tier, web tier. But again, similarly across the board, whether it's on-premise, whether it's in Amazon, or whether it's in AWS, right? Amazon or Azure, excuse me, right? The end result of this is when we go to look at the members for the group, again, this is the same group, book app group. You can see that it finds 2 VMs from AWS and 2 VMs from Azure. And in this one for the web tier, it finds 2 VMs from AWS, none in Azure right now, none on premise right now. But think about this. What happens if we added another web server in Amazon? What do I have to do? Nothing, just tag it, make sure it has the tag. And the policy would apply. What happens if I decide, Amazon is getting expensive, it's kind of cheaper for me to run the workload in Azure, or maybe I'm trying to roll out this application to another geography, and Amazon doesn't have a strong presence there, but Azure does. So I want to deploy this web server in Azure as opposed. Again, what do? Deploy the VM instance and tag it accordingly. The policy is already there. Something I promised we'll talk about is feature we introduced in 2.5. It still carries over the 3.0 called native cloud enforcement mode. Now, the way we've introduced this, or the way we've talked about this, has been from the perspective of we require an agent in the VM to be able to provide microsegmentation rule for it, right? If you remember, as we went through the steps, I showed you that in the workflow, there was a step that was not included. And the reason we did not include that was because now it's an optional step. Prior to 2.5, that wasn't an optional step. It was a required step. If you had 100 VMs or 1,000 VMs running in AWS or Azure, you needed to install the NSX-T agent into those VMs so that we could push the firewall rules down to the VM. Now, for clarity's sake, this agent is not operating on the Windows firewall in, say, a Windows VM running in Azure or AWS, nor is it operating on an IP tables in a Linux VM running in AWS or Azure. We actually inject a shim in the kernel of the operating system, and we install a open vSwitch, and that's where we do the inspection. So someone goes and turns off Windows firewall or IP tables. This has no impact on my security policies because we're not relying on that. But needless to say, yes, we are having, if we chose this option, to install something into the OS, no question about it. And there was no way around it back then because, again, we did not have access to the underlying hypervisor, not to mention the hypervisors are not vSphere. So in 2.5, we said, listen, with customers demanding, we need to be able to do things differently, right? We don't want to have to always install agents into the VM. We love what you guys are doing with the on-premise solution where I can deploy thousands of VMs and never have to worry about installing anything in the VM to make it work. I need to have that level of flexibility in the cloud as well. So we introduced what's called native cloud enforced mode. With native cloud enforced mode, you still write your policies just as you would, right? The difference is we don't inject it into the VM for inspection, right? We leverage the cloud-based security architecture. So your cloud-based security groups or network security groups in the case of Azure, we leverage those to provide the security. We actually will program whatever the firewall rules are that you write, we program them into, in the case of AWS, we program them into the security group, and in the case of Azure, the network security group. But that's what's happening there. And again, this does not require us to install any agents into the VMs. Now, something to be mindful of with this is, when you choose the option as to the enforcement mode, whether it's going to be NSX-T agent enforcement mode or cloud-based enforcement mode, you do it on a per VNET or VPC basis. In other words, this illustration here is showing me where I have Azure on one side and AWS on the other. Let's assume they were both AWS, right, as opposed to Azure. My point that I'm trying to drive across is, if I choose to do cloud enforcement mode on this VPC, again, let's assume they're all AWS, right? If I choose to do VPC, the cloud enforced mode on this VPC, then I cannot install the agents into these VMs and use NSX-T enforcement mode that way. I can't do that. It's one or the other. And again, it's per VPC or VNet. So because I've done that here does not mean that I have to do the same thing over here. Over here, I can go ahead and install the agent here, not a problem. But per VPC or VNet, I have to choose which way I'm gonna go. So here you see where this is showing us, in the case of cloud enforced mode, again, we're not doing this in the kernel or the OS level. We're doing this at the cloud level. We're using security groups or network security groups, as we stated. And again, what the slide doesn't illustrate is the fact that you have the flexibility, but you have to do it per VPC or VNet. I think my next slide actually harps on that. So let's take a quick look at it. Yes, it actually does. Flexibility of deployment, right? So if you notice, we have a situation here where, let's start from the left. Let's actually go through the whole process, see what it looks like. So on-premise, this is my on-premise, my private cloud. I have my NSX manager. I have my cloud service manager. Right? I've registered my cloud service manager to NSX, done. I've got one or more applications running on premise, right? In this illustration, we're using VPN between my on-premise and the cloud. So we're doing VPN here. It could be a direct connect, right? Or express route in the case of Azure. But here we're illustrating, we're using VPN, not a problem. What you do notice though is, we have kind of a transit VPC in place, right? So I've got this top level VPC here, and then I have these paired VPC at the bottom, right? The point is, I can choose my enforcement mode, per VPC or VNet, right? So I can essentially choose to deploy my public cloud gateway here. So all connectivity comes through here because it's a transit. But where I've done that, I can say, you know what? Over here, I want to use native cloud enforced mode. But over here, I want to use NSX enforced mode. So when I write security policies, right, for anything that's over here, those policies will be inspected and handled at the instance level using the shim that we inject into that operating system. When I write rules for instances that exist in this VPC or VNet, or even this VPC or VNet, right? Actually, this is NSX Enforced as well, so scratch that. For this VPC or VNet, then it doesn't do it at the operating system level. It does it by injecting the rules into the security group or network security group for AWS or Azure, respectively.
What happens if I move a VM from, say, Azure to AWS? Does it automatically detect that, or do I have to retag the VM somehow?
So that's a loaded question. Loaded, not in the sense of the technology that we are going through here, but loaded in the sense of that's not something you can just do by pointing and clicking, right? The platforms are different, Azure and AWS. Moving a VM from Azure to AWS requires you to do some kind of conversion, if you will, of that image, right? Now, when you convert the image, in most cases, at least the ones I'm aware of, what it's doing is it's taking a snapshot of the disk, right? Applying that disk in the instance of Azure to, say, a VHD or VHDX, and attaching it to a virtual machine there. So what does this mean? This means your tags that you had in AWS doesn't follow, because all we're doing is we're taking the disk, right? Imaging that disk into a disk format that's compatible for the other platform and attaching it. So you will have to tag it on that side, but once you tag it, you're good to go, right? It's not as same as, you know, if I were moving a VM from one on-premise to another on-premise environment where they're all vSphere based, right? It's not quite the same, because these are disparate clouds using different hypervisors, different technologies, and how they do things.
Great, thanks, Rodney.
So going back to a sample policy, again, if you remember, we said the policy construction is it's the same, not even similar. It's the same as what you would do for on-premise. You tag your workloads, you take those tags and make them the basis of your groupings, and you apply those groups in the firewall rule. So if you take a look, you see here where we have a rule that says anything destined to webhooks. If you remember, webhooks is looking for any VM that has a tag of of books, right? Or the web tier for books, excuse me, whether they were on-premise, in AWS, or in Azure. It was looking for that. And if that traffic is requesting HTTP or HTTPS, right, they will want to allow that. And we're doing the same thing here, from the web to the app layer for this service, and from the app layer to the DB layer for this service, we want to allow. Right, so you write the rules the same old way. You tag the VMs the same old way. You create your groups the same old way. So continuing through, you see here, right, what is BooksWeb? BooksWeb is any virtual machine that has a tag of web, right, in a scope of Azure app tier, and at the same time has a tag of web, of books with Azure app tier. So that captures your Azure machines. But what about if they were in AWS? We add another criteria number 2. We'll find it if it's got books with a scope of AWS app name, and go find it if it has web with a scope of AWS app tier. So it captures that web front end, whether the web front end is in Azure or it's in AWS. And again, if you had some on-premise, you just add a criteria for that as well, so that it captures those two. When we view the membership for that group, we can see that there is 1 Azure instance and 2 AWS instances. Okay? And the same is true for our book app layer, and also the database layer, which you would see in the next transition. okay? But again, you write the policies using the same NSX-T distributed firewall rule base, and you use the same constructs that it provides for tagging and for grouping. Nothing changes. The next thing is showing us an example of what happens if I do NSX Enforced Mode. Now, the first takeaway that I want to ensure that you carry with you is whether I'm doing NSX Enforced Mode, right? Or whether I'm doing Cloud Enforced Mode, that I'm still writing my policies the same way using the distributed firewall rule base. I do, however, have to take into consideration some of the limitations of the cloud platform. For instance, what if the cloud platform does not allow me to write deny rules, like you know who I'm talking about? Then that means you cannot explicitly write a deny rule. You need to write allow rules, right? Because the cloud platform already has a default deny rule, and it's just saying write the explicit things that you want to allow. Okay, so you want to take that into consideration. But the point is the structure and where you do the rules, whether it's NSX Enforced or Cloud Enforced, is still the same. So here we're showing you where we have written the rules, and now we go into the data plane to take a look at what the rules are that's applied. And you can see the rules as applied, right? We have an address set, and we're looking for port 443, that's for HTTPS, right? So we say anything to this address set, which is defining that grouping that we define. For this port, we're gonna accept. And similarly for port 80, same address set, right? And that's my web rule. And if you look closely, you will see the same thing for the, and for the DB. So I wanna switch gears now and talk about another multi-cloud solution that VMware provides, namely VMC on AWS. But in talking about that, let's open with what's the challenge with, you know, a standard multi-cloud as we have introduced it, right? That is, I have my on-premise, I want to move to native AWS, I want to move to native Azure. What are the challenges there? The challenges there, of course, is the fact that I have to transform or convert the virtual machine instance, because the instances are different. In VMC, we use AMIs, right? And that's not what we use, excuse me, in AWS rather, we use AMIs, and that's not what we use on premise. So we need to convert my virtual machine to an AMI, essentially, right? And likewise, if I'm moving to Azure, I need to convert that as well. So it's not a seamless right-click the machine and migrate it. It's not a seamless select the machine and drag it from one pane to the next and it moves. It's not that seamless. There's a lot of work that has to happen. In a case where you need to move 1, 2, 3, 4 machines, that may not be a big deal. In a case where you need to move hundreds or tens or thousands of machines, that starts to become a concern. And we start to ask the questions of, is there a better way for us to do this? Is there an easier way for us to do this? And VMware, of course, provides us a solution for this on AWS. There are other solutions, similar solutions that are available for other cloud, but those are not provided by VMware. Some may be supported 100% by VMware, but they're not necessarily provided by VMware. Some other partner is providing that. But for the AWS solution, what we are calling VMC, VMware Cloud on AWS, this is provided by VMware. It's supported 100% by VMware. The VMware staff is the one that's building and supporting the architecture, right? And it's for the most part, right, as far as the physical components are concerned, it's hands off from you. So you don't touch that. You don't touch the ESXi host. So when it comes time to upgrade them and things like that, that's not your concern. They take care of all of that for you. But needless to say, getting back to our slide here, on-premise vSphere deployments, right? So what if you find yourself to be a customer and you were concerned about some of the things we just pointed out? I need to be able to migrate VMs, right, without having to worry about this whole conversion stuff, right? Because converting a machine takes time. If that is a production machine, something that's in production right now, and I'm converting it, there are changes, right, that I'm concerned with. Essentially, I need to find a downtime to power it down, to convert it and move it. Well, what if it relied on some other machine and I've moved it, but the other machine is still not moved as well, right? There's all of these things I have to concern myself with. And now that I've moved it, do I have to re-IP it because essentially it's in a new environment on a new network? And if so, how do I ensure connectivity? And all of these concerns, right? And then on top of that, I'm a vSphere admin. I've been doing this for ages. Are you now telling me I now need to go learn a new platform? I need to learn a new interface, the Azure interface or the AWS interface? Well, yeah, you do. Well, we're saying with the solution we're about to propose and discuss, you don't have to. It's the same or similar interface, right? Can I leverage my existing monitoring tools that I have, right? My existing licenses that I have for these tools from VMware to monitor the environment? How do I bulk migrate, right? Especially if I wanted to move 100 VMs, for instance, at a time. And how do I ensure connectivity after they're moved, while they're being moved, and most certainly after they're moved? So these are some of the concerns that your standard public cloud offerings, the likes of AWS and Azure, doesn't necessarily provide, and those are things that you have to solve on your own. That's not to say they're not solutions for them, but they're things you have to solve on your own, and it can be kind of a pain for some customers. So for this, right, we introduced VMC on AWS, and alongside VMC on AWS, we also introduced HCX, both of which I will talk about. Essentially, providing a platform to allow organizations to harness the power of hybrid cloud and multi-cloud without having to worry as much about the operational aspects of it, right? Now that I'm doing it, how do I operationalize it? What are the tools I use? What's available to me? Do I have to learn something else? So on and so forth. And am I now managing 2, 3, 4 different things in different places? All of those concerns, right? So VMC on AWS, as I pointed out, is an as-service offering from VMware, right? So it's something that you subscribe to, it's subscription-based, right? It's a modern SDDC, so it's built on the VMware's SDDC stack. I'll talk about that more in the upcoming slide, right? But all of the tools that you've heard of and even use, they're part of that stack, right? Primarily NSX. NSX-T is in that stack, right? It provides for easy movement of workloads from one to the other. You can do a vMotion migration from your on-premise into VMC and AWS. No conversion required. It allows for integrated direct access to your native AWS services. Huh? What do we mean by that? Well, what if I had an elastic load balancer service in AWS, and I have now deployed 2 web servers in VMC on AWS, and I wanted to use the elastic load balancer for AWS to load balance those VMs. Can I do it? Answer, absolutely. What if I wanted to use the Amazon Route 53 for DNS? Can I use it? Absolutely. Right, so all of those Amazon services, those native services, can be consumed by VMC on AWS because VMC on AWS is sitting right next to them, right, within the same availability zone. Or generally, you would want to have them in the same availability zone. They don't have to be, and there are challenges with that if they're not, but you want them to be in the same availability zone. So essentially, if I'm an existing AWS customer, and I have, AWS services running in US East, then my point is I want to ensure that when I subscribe to VMC on AWS, that I'm running it within that same region and availability zone. I don't want to run it somewhere else. Because the first challenge I'm going to have, which I may not notice until the end of the month, and will really tick me off, is my egress charges, right? Don't want that. If they're within the same region, you don't get egress charges. Right? Then, of course, there's all the connectivity plumbing that you have to do. So, and of course, if I'm trying to modernize my applications. I'm looking at moving forward into the future with containerization and so on and so forth, right? And I want an easy way to move to that, especially where I'm considering leveraging AWS as the platform for my containerization. Then it allows me to kind of coexist in that environment, if you will. So let's take a quick look at what's in the stack, this modern SDDC stack, right? Well, this stack is going to have vSphere at its base. It's going to have vSAN. It's going to have NSX, all of the things you already know and love, right? Again, right next to that stack, you want to have your AWS services. So you're going to want to be in the same region. You want to deploy VMC and AWS in the same region. It's important to note that VMC and AWS is currently not in every Amazon region just yet. We're in most. There's like 2 or 3 we're not in just yet, but we're in most. The point is, when you go when you subscribe to the service, and more importantly, when you deploy the service, when you go to deploy your SDDC, you want to be very careful to ensure that you are deploying in the region where you currently have service. If you currently have these services, and you want to be able to consume them seamlessly and economically. So let's assume, for instance, you bought in on this idea of VMC and AWS is great, especially when you consider the climate we're in, right? Let's say you decided, I want to do this because I want to leverage some virtual desktops, right? So, and I don't have the capacity on site to roll out my virtual desktop, because now where previously 10 to 15% of my workforce worked remotely, I'm having to, juggle with the idea that 80% or more of my workforce needs to have the ability to work remote, right? So I need capacity to do that, and I don't have the capacity. I'm a vSphere-based shop, and here's an option where I can subscribe to services from VMware in the name of VMC and AWS. So you do just that. You deploy some VDI desktops there. And over time, you realize for performance reasons, all right, there are some applications that the users in the VDI environment use, and you want to have those applications brought as close as possible to the VDI users, right? This is not to say that you intend on maybe migrating all of them 100% over to VMC and AWS, but maybe that's what you want to do, first of all. Or maybe what you also wanted to do is you wanted to burst them into VMC and AWS. That is to say, maybe you have 2 mail servers on premise right now. You don't want to migrate both of those 2 mail servers, but you want to burst. You want to add a 3rd mail server, and you want that to be on VMC and AWS. But needless to say, you want them to be on a seamless network, a layer 2 network. The question is, how do we do all of these things, and how do we do it seamlessly? The answer is, with your subscription for VMC and AWS comes HCX, Hybrid Connect. With HCX, it allows us to provide this measure and level of hybridity, right? What does it allow us to do? It allows us to, A, migrate workloads from any SDDC stack, starting with vSphere 5.x, over to a modern SDDC stack. So let's evaluate that comment for a moment. Let's say your on-premise environment was running vSphere 5.5, right? And I wanted to live migrate some VMs into VMC and AWS. Question is, can I do that? Answer is no. Why? Because you can't do long-distance vMotion with vSphere 5.5. That feature was introduced in 6.0, and you don't have 6.0. So if you want to migrate, sure, you can power off those VMs and migrate them. That's one option. But again, I don't want to do that. I want to do a live migration. I can't do that. Right? What allows me to do this? HCX. Using HCX, I have the option to migrate those VMs, even though the platform, vSphere 5.5, doesn't support it. Because HCX is designed from the ground up of migrating across wide areas, it provides capabilities that your standard vMotion doesn't. The likes of compression, deduplication, right? essentially WAN optimization, right? vMotion doesn't care about that because vMotion was designed to be a, local area network technology to move stuff from one server to the next on the same layer 2. That's how it started. Now we provide support for it for layer 3, but still, for the most part, it's concerned with ensuring that we can do this in an environment that's close. And now that we support long distance, we still have requirements like 150 milliseconds round trip latency and all that kind of stuff. HCX says, I don't know where that stuff is going to be, and you're going to be migrating over a WAN. So I'm going to go ahead and optimize things for you. You have the option to do things like that. Right? It also allows you to do bulk migration, speaking of migration, where I can grab 100 VMs and migrate them at once. Very unlike vMotion. Yes, in vMotion, you can select 100 VMs and say migrate, but guess what? It will be staggered 8 at a time. Here, I am actually migrating 100 concurrently, right? And it also allows you to stretch your layer 2 should you attempt to do that. So going back to my example of my mail server that I want to add a third one to, I want to essentially burst, and I don't want to change the network as I'm, deploy this third mail server and migrate it over. I want it to exist on the same network as the other two, since they're clustered, right? HCX will allow me to stretch that across these sites, whether or not my on-premise has NSX. So my on-premise doesn't even have to have on NSX. It allows me to stretch the networks. And so these are the capabilities, just in summary, if you will, that it brings to the table in ensuring that we can actually achieve this level of hybridity and multi-cloud that we require. First thing I want to talk about in these couple of things that I yet have to cover is what have we seen has been some of the key use cases, right, for people moving to VMC on AWS. Data center extension is one, right? I use the example of the climate we find ourselves in today with COVID-19, right? We have a need now to move or provide at least that option for a vast majority of my workforce to work remotely, where before it was just a handful that did, but now everybody needs to. And again, I don't have the capacity on site to do that. It's going to take time for me to order those servers for them to come in. It's going to take time once they're in for me to set everything up and get ready. Meanwhile, people still need to be productive. Business must still go on, right? So I want to be able to burst my existing VDI deployment into the cloud very easily, right? So I want to extend my data center. Again, great use case for VMC and AWS, and we've seen a lot of customers do that since its inception, and especially now. Another use case is disaster recovery. A lot of customers are trying to move away from the data center management business, right? I don't want to manage physical data center 4 walls and that kind of stuff. At the very least, I don't want to manage a second one. One is enough. I've got one primary one, and I'm locked into that because we just built it a few years ago. We spent millions of dollars getting that up and running, but I don't want to have to go through and do a second and maybe even a third one, right? I want that to be someone else's problem. I want to have the capacity available when I need it without having to pre-purchase it, because in the case where I'm standing out my own DR solution, I have to have those servers. I can't wait until there's a failure to purchase servers. I have to have them. I can subscribe to VMC on AWS and leverage, for the most part, right, most of the storage, because that's what I'm replicating. This is not to say my subscription will not include servers. It does, but the point is my subscription doesn't have to start with 20 servers. It needs to start with enough capacity to account for the machines that I'm going to migrate. Now, in the unfortunate event of an outage, when we start to bring those workloads on in VMC on AWS, guess what it can do for me? It can automatically add capacity. That is, add additional servers above and beyond the 4 that I have, so that we can ensure that we have not just the storage capacity, which we already took care of, but we have the compute capacity to run the workloads. All right. Then, of course, there's cloud migration. Some customers are trying to get completely out of the data center business, right? I want to get completely out of the data center business. Maybe I'm a new startup, right? And we had a little closet, server closet, where we did all our stuff, and we're now ready to go prime time. I'm now ready to take on Netflix. My code is ready. I don't want to have to go build a data center to compete with Netflix. Right? The point is, migrate this into the cloud. And one cloud that you can do this for, especially if your existing images were based on vSphere, to make that seamless and easy and timely, is to use the VMC on AWS solution. Keeping in mind, the VMC on AWS solution is across the globe in most of AWS's data centers. So even if you needed to provide services in Europe and now even in Africa, you can do that because VMC on AWS has presence in all of those data centers across the globe. And again, finally, what about next generation applications, right? I want to have a modern infrastructure in which I can start to develop container-based application and have those applications consume cloud-based services provided by a cloud provider, the likes of AWS, right? Again, we can do that. And that's another heavy use case that we see. So speaking of disaster recovery, the disaster recovery capabilities of VMC and AWS leverages Site Recovery Manager, the Site Recovery Manager solution. In VMC and AWS, we just call it Site Recovery Service, right? But it's leveraging that same architecture and the same set of tools. The slight difference is where on-premise Site Recovery Manager, you have the option to do vSphere replication as well as array-based replication. Here, it's vSphere replication only. We're replicating at the VM level, not at the array level, right? Because we're trying to replicate into VMC, and VMC uses vSphere, right? But it uses that same technology. So if you're familiar with it, all we've done is we've taken the technology and SaaS enabled it and attached it to VMC, which you can now enable and configure. But with that, we can have non-disruptive testing, right? I can do a failover test, just as I can in standard SRM, where the workloads will be placed on an isolated network, kind of a bubble network, where I can test. You know, I can either have Site Recovery create an isolated network for me. The concern with having it do that is that network wouldn't have any uplink to get out, so you have no way of getting into it. Or you can pre-create some test networks, and when you design your recovery plan, you tell it to use those test networks, and those test networks could be routable, so that now when I do my test, not only do the VMs come up on this extra network to the side, right, but there's connectivity. There's a means for me to get into them and test them, right? Because I don't simply just want to test the failover steps to see VM1 came up, VM2 came up, VM3 came up, and they're coming up in the order that I specified. But I want to also test that the application is accessible. Because in an actual failure, that's what we require. Or after an actual failure, that's what we require. We require to bring these applications up and have them readily accessible. And you can also do automated failback, right? So in the event, I live down here in Florida, and we're prone to hurricanes. In the event where we get notice for hurricane, if I had a VMC and AWS solution, the point is I can fail over into VMC and AWS. Oops, hurricane's turning away. It's now going back into the Gulf. Oh, no problem. What do? Fail it back. So as opposed to paying for 20 servers for a prolonged period of time, maybe that failover event just happened for 48 hours and I failed it back and I returned back to regular billing, right? You can have automated failover as well as full detailed reporting about each failure testing, failover, and failback. So, in closing, as it relates to VMC on AWS, VMC on AWS streamlines your migration experience, right? When you're migrating to the cloud for customers looking to leverage hybrid cloud or multi-cloud, and don't want to have to worry about essentially transforming or converting their VMs, right? The VMC and AWS solution is leveraging vSphere with NSX with vSAN, right? It's providing you a similar set of tools that you can use, right? Going back to VMware, or NSX Cloud, excuse me, NSX Cloud allows you to provide the measure of multi-cloudity where you're trying to do on-premise with native AWS and native Azure, not VMC on AWS. Okay. Thank you, everyone.